Hello and welcome everyone. I hope you all doing great and you all have completed your computer forensic section from my previous lectures. Okay, and hope you all are getting notes from this WhatsApp community. If you haven't joined the WhatsApp community for notes, please do join this. Okay. Then today we'll start with our network forensics. Okay. So let's begin with our computer networking first. So in computer networking, we have two kind of signals. One is digital and another one is analog signals. So analog signals are continuous waves which transmit the data. Okay, and they were used in basically in traditional landlines and radio frequencies. Okay, so means analog represents continuous data using various voltage levels or waveforms, and in digital signals it represented discrete data using binary values 0 or S. And as we all know that digital signals are used in computers, smartphones and digital sensors. Okay, so I have written some key differences here like signal type. So analog are continuous one and discrete signals are digital signals. Okay, then about processing, analog required much processing than digital ones. Then about storage, analog store less data as compared to digital signals. And about bandwidth, analog typically require much bandwidth because they travel in a waveform, and then digital require less. Okay, and error resistance, as we all know that digital signals are more resistant to error and distortion as compared to analog signals. That's why we are in like digital world now, because we are getting access to data very fast. Okay, now the type of network and topologies. So network is divided into four different types: PAN, LAN, CAN and MAN. PAN means personal area network. Okay, which helps in a connection with one device with one particular person. For example, in a range of 10 meters using Bluetooth. Okay, and it uses the topology, star topology or mesh topology. We will discuss the topologies in like next slides. Okay, so now local area network. Local area network means it connects a small group of computers within a limited geographical area, such as building. Okay, and for example, in local area we can connect through Ethernet or Wi-Fi. Okay, and it uses the topology, star topology, bus and ring topology. Okay, the next one is CAN. CAN means campus area network. A CAN connect multiple LANs within a limited geographical area, such as university campus or corporate office parks. Okay, it is larger than LAN but smaller than a MAN, and it uses the hybrid topology. Okay, then about MAN. MAN is Metropolitan Area Network, which covers larger regions, including small towns or cities. Okay, and it uses the fiber optics to send the data. Okay, and it uses the topology, hybrid topology, and ring topology. Okay, then last one is WAN. WAN is Wide Area Network. So WAN spans even large areas, such as entire country. Okay, it connects networks across a long distances. Okay, it uses the internet. Okay, then about topologies. So topologies are of various kinds, such as star topology, burst topology, ring topology, mesh topology, tree topology. Okay, so in star topology, as we can see in picture, so in picture here also, star topology is this. So one center hub is connected to another hubs. Okay, so means a central hub with spokes connecting to nodes to another hubs. Okay, then next one about bus topology. Bus topology, as you can see in the picture here also, this one, a single backbone cable with nodes connected along it. Okay, and hubs are connected with through this backbone cable. Okay, so next is ring topology. So ring topology is here. So in ring topology, nodes connected in a closed loop and each connected to another two. Okay, next two hubs. Then next one is mesh topology. So in mesh topology, as we can see in picture also, every node is connected to another node, every another node. Okay, Then tree topology. As you can see in the picture, also tree topology looks like a tree. So basically tree topology is a combination of star and burst topology with nodes branching off from a central node, okay, in a hierarchical manner. Then about hybrid topology, a combination of two or more different topology is known as hybrid topology, as you can see in picture also. Move to the next topic, that is OSI. OSI means open system interconnection. Okay, so this model basically help to understand the process that how computer communicate with each other and also over the internet. Okay, so this OSI model was proposed by Herbert Zimmerman in 1978, but it was created in 1984 by ISO. Okay, so consists of some layers. So OSI model consists these 7 layers. First layer is physical layer, then second is data link, then third is network, then fourth one is transport layer, fifth one is session layer, and then sixth one is presentation, and seventh one is application layer. Okay, so let's understand the function of these layers. So the first layer is physical layer, so which is responsible for active physical connection between the devices and transmitting individual bits. So here raw data is transferred in the form of bits. Okay, then second layer is data link layer, which manage communication between directly connected devices, and it framing the data into frames and handling error detections. Okay, so here data travel in the form of frames. Okay, and over the physical address, as we all know, physical address is MAC address and logical address is IP address. So data travel in the form of frames over the physical address. Okay, then third is network layer. Network layer routes data across different network using additional logical addresses, that is IP address, to determine optimal path. Okay, and now data is converted into packets. Okay, then come to the fourth layer, that is transport layer. So this layer ensures reliable end-to-end connection or end-to-end communication and handling the segments, flow control and error recovery. Okay, so basically now packets get into the form of segments. Okay, and any kind of error will be recovered in this portion only. Okay, so move to the next layer, that is session layer, which establish, maintains and terminate communication sessions between applications. Okay, so this is also like called inter-host communication layer. Okay, then next one is presentation layer. So it translates the data and encrypts and compress data for application compatibility. Okay, like according to viewer it presents the data. Then next one is application layer. So this layer provides network services directly to user application. Okay, so this is how you are getting your data over the internet. Here also I have written the function and responsibility with examples of each layer. You can study this by your own. So starting from this physical to till 7th layer. Okay, you can study this table. Now come to the protocols which OSI model use. Okay, so here are two protocols. TCP is transmission control protocol and IP is internet protocol. Okay, so what is the function of TCP? So it ensures reliable and ordered delivery of data. Okay, and IP address is for responsible for addressing and routing data packets. Okay, then TCP gives guarantee about data delivery and IP does not give data guarantee. About mechanism, so TCP uses sequencing and acknowledgements for reliability, and IP relies on the network to deliver data reliability. So IP work in network layer. Transport layer uses the TCP protocol to send the data in the form of segments. Okay, so next is IP address types and classes. So we have 4 kind of IP addresses, that is private, public, static and dynamic. Okay, so let's study one by one. So first one is public. Public IP address means that it can be accessible over internet and it is different for entire web. Okay. Then private network. Private network means that is used within a private network and cannot be accessible on internet and basically used in local area networking. Okay. Then third one is static. Static means the IP address which is fixed to one computer or device and it remains same. Okay, it does not change. Okay. Then fourth one is dynamic IP address, that is basically assigned by DHCP. DHCP is dynamic host configuration protocol server and this IP address changes over a time. Okay, means again and again this IP address changes. Then move to the classes of IP addresses. So we should know that classes of IP address is divided into only five parts: A, B, C, D, E. Okay, so basically A comes in the range of this, like range is written here, you can study, and default mask is also written here. So B is having this range, so you can study this range, guys. Okay, you can remember this range. This is a very easy one. Last letters are same for this, and D is used for multicast and E is used for experimental purpose. Okay, so last time question came in fact examination that which is not a class of IP. So they have mentioned this A, B, C, D, E, and F maybe. So the right answer was F, because F is not a class of IP address. So very simple question will come, guys. Don't worry about it. Okay. So you can study this table for range. Okay. Then about masking. So what is masking, guys? So masking identify the boundaries between host ID and network ID. Okay. So it just see the length, like this till this portion it is host ID, and from this next portion this is network ID. So it just give the length to this ranges. Okay. So it is for the, so masking is for the dividing to subnet mask, supernetting, and subnetting masking. So subnet mask means a 32-bit number that separates the IP address. So in subnet mask, only 32-bit number is used to separate the IP address and network address. Okay, so only 32 bits used in the subnet mask, and the first portion is separate the IP address, and the next portion is host portion. Okay, or host ID. Okay, so purpose, because to identify network part of an IP address and determine the size of the network. Okay. Then supernetting is also known as root summarization and root aggregation. Okay, so this is basically a process of combining smaller network into a larger one. Okay, purpose to reduce the complexity. Okay, between multiple networks. Then come to the subnetting. Subnetting means the process of dividing a larger network into a smaller subnetworks, which is just opposite to supernetting. Okay, so what is the purpose of this subnetting? To create smaller, more manageable networks within a larger or big network. Okay, so you can see the example here. So for class C IP address, a typical subnet mask is this one. So I have already written in my this table also that if IP address of class C is this, so 192.02, this thing, so subnet mask will be 255.255.255.0. Okay, and here 24 bits for network and another 8 bits for host, so it uses the 32 bit totals. Okay, then example of this supernetting. So combining this particular range network into a larger ranges. So when we are combining some IP addresses and we are making that IP address is a big one or big network, so that process is known as supernetting, and opposite to that thing is subnetting. Okay, means just dividing the larger network into a smaller one. Okay, you can see the example here also. Now come to the next thing, that is networking hardware devices. So we all heard about these hardware devices: router, switch, hub, bridge, gateway, modem, network interface cards, access point, repeaters. These all are hardware devices to give internet connection. Okay. So now then router and routing protocols. So router is basically used to provide the data, and it gives the data in the form of packets between a computer network. Okay, then it uses some protocols such as OSPF, BGP, EIGRP, and RIP protocols. So here I have written the full form of these particular routing protocols. You just go through it, guys. Only full forms can be asked. Not much detail will be asked about this thing. Okay. So till here we have covered our network forensic part A. Okay. So we'll meet in our next video. Till then, study, guys. Bye bye.